lava. I'm going to do a parabola graph for this lava fountain. I love this lava fountain picture because it really illustrates the way gravity causes things that are sailing through the air to form the very familiar parabolic pattern, which can be modeled with a quadratic polynomial. And there are three basic ways we can structure our polynomial. I'm going to be we're working at the beginning of this with the idea that polynomials are products of linear equations. So I'm going to create a linear equation and try and get some aspects of it to be close to this. Now, if I simply make this linear equation, y equals x minus 1 times x plus 1. I get this nice little parabola. And it's got x-intercepts at 1 and negative 1. But it's not matching anything, really. It's got sort of the general same shape. It's just pointing in the wrong direction. So one thing I can do is I can get it to point in the right direction. So since this lava fountain goes up and then comes down in a parabolic state, I can just put a negative in front of it. And now that's a down parabola. All right, now I need to do some adjustments to my x-intercepts. Now, it turns out the x-intercepts of a parabola are going to match the x-intercepts of any particular linear equation. So if I took just this linear equation here, and I put it here, x minus 1, notice that I get an x-intercept at 1. That is going to be the same as one of the x-intercepts of our parabola. If I had 3 or 4 of these being multiplied, every intercept of your polynomial squiggly wiggly that you end up graphing is going to match an x-intercept. The x-intercept of this is what x is when y is 0. So when y is 0, I get x equals 1 because 1 minus 1 would equal 0. All right, so since that's actually my x-intercept currently, but I really want an x-intercept over here near 8, I'm going to make that one x minus 8. So if x was 8, I want this to equal 0. So it's going to be x minus 8 because 8 minus 8 would be 0. So that's cool. I got my x-intercept in the right position. Now I need to figure out what I'm going to do with the other x-intercept. Now my other x-intercept is what x would be for x plus 1 to be 0. Currently it's at negative 1 because negative 1 plus 1 would be 0. But that's not the other end of this parabola. Now, parabolas are symmetrical, and that's a very helpful thing. So from 8 to about the top of this, looks like my x value is 1. So it looks like I have this thing is kind of divided by a vertical line at x equals 1. And we can show that x equals 1. You can kind of see it goes through about the middle of this. So what that tells me is my other side, my other x-intercept should be, so that's from 8 to 1 is 7. It should be 7 in this direction. So 7 away from 1 in this direction is going to be negative 6. So I need this to work for negative 6 plus something equals 0 and negative 6. So if x was negative 6, if I added 6 to it, I would get 0. So now I've got, I think I've got pretty decent x-intercepts. But I've got the whole thing in the right direction. I'll zoom out so you can see the whole thing there, whoop, way up there. So I've got the whole thing going in the right direction. I'm going to zoom back in a little bit. I have a couple ways I can work out what I need to scale this down. A couple ways I can work out what I would scale it down to. I'm going to start off by just doing the eyeballing approach. If I made it times negative 1/2 instead of times negative 1, it does get flatter, but that's not enough. How about 1/3, 1/4, 1/5, 1/6? We're getting into the right area. 1/7 is too much. 1/6 is not enough. So I'm somewhere in between. So I can fiddle around with the fraction and get it somewhere between 1/7 and 1/6. Or what I could do is I could take a look at what is my x-intercept, or my y-intercept for this thing. My y-intercept is what I would get if x was 0. Now we can see it on the graph that the y-intercept is 48 right there. Now, where does the 48 come from? Well, 6 times negative 8 is negative 48, and then times negative 1 makes negative 48 positive 48. And why 6 times negative 8? Because that the y-intercept x is 0, so I don't even care about this x. This is 0 minus 8 times 0 plus 6. So 0 minus 8 times 0 plus 6 is going to be negative 8 times 6, negative 48. And then I flip it by making it the negative of the negative, which is the positive. Cool. All right, so I know that y-intercept is 48. Let's go down and see what the y-intercept of my lava fountain is. Well, it's somewhere right around here. And that looks to me like, well, that's 7. That's 7.5. So maybe it's at about 7.25. So maybe what I need to do is figure out what I could do is I could just make a fraction of 7.25, 7.25, and divide that by the actual y-intercept of what I had and make that 48. And I'm pretty close to nailing it. It looks to me like maybe I need to move this y-intercept out just a little bit. So I'll make that maybe 8.2, 8.3 maybe. And then I'm going to probably have to adjust my multiplier a little bit. So I'm going to adjust my multiplier. Now I have a new y-intercept that's 8.3 times 6. So 8.3 times 6, or negative 8.3 times 6 times negative 1. So I've got 49.8. So let's go ahead and say 7.25, which is this, divided by 49.8. And I think that's a little better. I could keep tweaking it and working it out, but I've got a pretty good model here. So I had to come up with a scaling factor to make the parabola smaller, as small as this parabola is compared to what my basic parabola was. And I figured out, okay, that's what I want my y-intercept to be. 49.8 was what my y-intercept was once I made this little adjustment. Of course, I had to make it go down. That's why there's a negative. 8.3 is one of my x-intercepts. That's over here. And 6 is my other x-intercept. That's down here. Okay, so 6, negative 6, and 8.3. And I've got a y-intercept right here at 7.25. Okay, I hope that has given you some stuff that will work for you. If you want, I'll do one more. I'll bring in one more parabola. Actually, I gotta bring it back to the middle because it's gonna show up in the middle. Let me turn that off. I'll turn that off, and I will just import another image. I'll import an image right here. Let's see, let's import an image from quadratics and polynomials. I'll import this lovely arch like that. And this lovely arch, currently I can move it, by the way, grab this and move it around. I'm going to move it so I get a reasonable x-intercept. Let me go over here. I'll use maybe 10 as my x-intercept. And yeah, that's about right. And now I feel like I ought to rotate it just a little bit because I think we're good. I think we're good. So I'm going to use this as the main parabola. It seems like some extra stuff broke off here, but right here is what I want to match. So what I want to do is I'm going to get, looks like I'm actually going to end up, I'm going to move it a little over so that 9 is going to be one of my x-intercepts. And then over here, it looks like I'll have 3 as my other one. Okay, so I'm going to assume that I'm aiming for 9, 0, and 3, 0. Those are going to be the intercepts I seek. Okay. Right, I might decide to change them slightly. So I'm going to turn this into x minus 3 times x minus 9. Okay, and so I get that. I have to have, now Desmos, you might notice Desmos recognizes that I really mean y equals or f of x equals this. So I'm just going to do this like this because it'll be easier to copy. And I'll put a negative. And now I am a little bit too steep. Now, this time I don't have a y-intercept to work with, but I do have a high point. Now, there's another point that you could consider in a parabola. It's called a vertex. I've got a vertex at 6, 9. Okay. And now I have a vertex for this parabola that looks to me like it's at 6, 1.5. So what I need to do is I need to figure out what would I multiply 9 by to turn it into 1.5. Okay, well, 9, so I'm going to multiply this. The thing I would multiply 9 by to get 1.5 would be 1.5 over 9. And I have pretty much nailed it right there. If I want to, I could, of course, turn that into 3 over 18, and then it'll become apparent to me that that's the same as 1 over 6. So 1 over 6, and I have got my parabola. I hope that has helped you in working things out.